Hello and welcome to another tutorial. So this time we are going to be taking a look at something called a level of detail or LODing. So we're going to be looking at it from 2 points of view. So one is the main area that we tend to see this in, where we're talking about from a visual point of view. So being able to use lower detailed models when we are further away so that we're able to render more complex scenes and to render things more efficiently. So that's one of the things we're going to be looking at. We're also going to be taking a bit of a look at how we could do LODing from a gameplay point of view as well, because the idea of level of detail, while graphics is the main area that we apply it to, or certainly is the most common area we see it applied to, absolutely is applicable to other areas and can be really handy to be applying it to our other systems also. So let's dive on in. So what I'm going to do initially is I'm going to set up a very simple LOD and set up a very simple one to really clearly illustrate the changes, because it's something where LODing done really well, and if we are able to sort of align things up really nicely, you actually can't tell that it's happening, which is cool. So I'm going to set up something where it's really obvious that it's happening. So firstly, let's set up an object that is going to be LODable essentially. So level of detail object. So to it, I am going to add in a component LOD group. So LOD group. So the parent object then has the meshes under it. So when we're setting up something from a visual LODing point of view, what we do is the meshes go under a parent object. And that parent object has this LOD group, which controls when and how that fading happens. So I'm going to create 3-4 different objects under this. So you can see it's got 3 different LODs defined here. We can control how many ones get defined. So the first thing I'm going to have is I'm going to put in a quad. So this is going to be, we might call this LOD 3. So higher numbers with a LOD, convention generally is that is a lower detailed version. So we've got our, I'll actually call that 2. Then I'll have a cube, and that can be LOD 1. And then finally, I'll have a sphere. So it will be mesh LOD 0. So we've got our 3 different LODs here. You know, a sphere obviously has significantly more geometry than a cube, which also has more geometry than a quad. So that quad could also be something like a sprite, and so it could be a billboarded sprite that always faces the camera as an option there. So we have our 3 LOD categories here. So I'm going to, what we do is we add in the renderers. So I drag in LOD 0, LOD 1, and LOD 2. So these mesh objects typically won't have anything like a script on them, stuff like that. They won't have those components there. We'd also typically probably remove these colliders because the collider shouldn't really change shape. So we'd actually set the collider up on the parent here. So that we've got the collider isn't changing. Now we could potentially simplify the collider. Mostly where I would be doing that is something where it's a case of, okay, at larger distances we might use a simple primitive like a sphere or a capsule or a box, whereas at closer range we use full mesh collision. That would absolutely be an option there, but we're focusing just on the visual side. So what we'll notice, so we can see how it's saying culled. So when something is beyond our last LOD, it actually won't render it. So as I get closer, we see it jumps to the quad. And as I get closer again, jumps to the square, or the cube. And then closer again, and it will jump to the sphere. Now in terms of where these jumps happen, so we can control based upon the percentage here of the screen size. So if I lower this, you can see that it will spend longer at this higher LOD. So here, that's with it lowered. If I drop that back down, then it's gone down a LOD level. So we can actually control this. And it does give us a really handy indication here of, okay, how many triangles is it trying to render? How many, submeshes, things like that, which is a good way of being able to tell what sort of level of saving we're getting. And it even gives us an overall percentage compared to LOD 0. So at close range, we're rendering 768 triangles, but at longer ranges, we're only rendering 0.26% of that. Now, what if we wanted to vary the distance that this happens at? So we've got a couple of ways we can go about doing that. So you can see here it's mentioning this LOD bias. So if I go to our project settings, what we'll find is we do have a setting for our LOD bias, which is under our quality section. Now, if you're running with a different platform, it's a different sort of render pipeline, maybe on the actual render pipeline asset, but in this case, it's on the quality one. So if I shrink this down so we can see it at the same point in time. So, okay, the LOD bias is currently 2. Well, let's find out what happens if I change that to 4. So that's extended out the range. If I change it to 8, it's extended it even further. So the LOD bias gives you a global setting that you can control, which will result in things being culled a lot sooner or a lot later, depending upon what you need. So you could tie that into quality settings. You could tie that into a particular setting you expose to the user of being able to vary that LOD bias. So that allows us to, at a global level, change everything. You also, and this can be a really handy option if you need to really cut out particular LODs if you've got a massive difference in terms of the platform capabilities. This, I could, if I get up to really close, this maximum LOD level, if I change that to 1, it'll never render LOD 0. So we've got a couple of controls there that allow us pretty significant capability to vary sort of where these, how efficient our rendering is going to be and how much we're trying to render, which can make a big difference. So, just going from 768 to 12. Now, these are with a LOD that is very, very clear to see the difference. But we'll have a look in a moment at one where it's less clear the difference, which is kind of the point. We can also vary our object size here. So you can reset the object size if you need to drop it back to 1, but this allows us to vary what the actual size is. Now, if I recalculate bounds, it's going to properly calculate the sort of size of it there. But say I did something like this and increase the size of that. This is now taking up more screen space, and it's picked up there's a change. So if I recalculate bounds, that's now at 3. So it means the distance that it would have changed LOD at pushes out. So the size of things, if you do go and update the size, do make sure you go and recalculate the bounds there, because that's going to make a big difference. We also have control over things like the fade mode. So something like the crossfade, what will happen there is, so I can set the width of the transition. So say I set this to 0.5, then, and I'll set all of these to 0.5. because it's actually a little bit easier to see. So I've set the transition widths to 0.5. Now it'll actually be pretty difficult to see the transition happening. Even if I get really precise to the point, I can adjust the range here, will make it a little bit easier to see. But what I'm actually going to need to do for us to be able to see this is I'm going to make the quad larger. And then what I'll find, so we can see we've got at particular points, we have this transition range here where it's actually going and is able to be rendering both. So that's something that can be really handy for smoothing out the sort of variations that we can actually see. So that avoids sort of popping. Now it's going to be hard to avoid popping entirely, but we can generally minimize the amount that we tend to see it. So, okay, we've seen with something very simple like this that makes it very obvious. What about if we use something actually practical? So I'm going to create a carriage, and I'm going to put this over here. And what I've got for the carriage is, this is from a previous game. So I have a bunch of these meshes, and we're going to give them all a material. So we've got those over here. Just going to reposition those a little bit. That's better. So that's our high detail one. Then we bring in our other set. I'm going to put them at the same position and give them their materials. This is something where they do support different materials because it's completely different mesh renderers. So as well as having the geometry be different, you can have the material be different, which means you could have different shaders. So you could have much cheaper shaders at a distance. You know, at a distance, you don't need ones potentially that have shadowing support on it. So you can turn off things like that to make it much cheaper at a distance. So I'm going to, under this, create an empty for LOD 0, which gets all of these. And I'm going to create an empty for LOD 1. Then I set up my LOD group on the carriage. Now, in this case, I've got a few renderers, which that's okay, because I can just add multiple ones in here. So we're going to add in each of these. And we can see we've got quite a lot of triangles. You know, this has 758,000 triangles. If I set up LOD 1 and bring these over, got that. So you can see that is 36,000 triangles. So that is about a 20th of the number of triangles that it actually has for the previous one. So what I could do then is I could extend out sort of where this actually happens. So this LOD 2 I might want to largely get rid of. Maybe I could have it be there. It's not really going to actually do anything, that LOD. But let's bump that to 20, and let's change that to maybe 70. Actually, no, less than that it should be. So, okay, we are getting closer. We're at LOD 2, but obviously LOD 2 isn't visible at this point. We could adjust the size of that, so we effectively get rid of the LOD. So now we're on LOD 1. We get closer. Now at this point, it hasn't changed it. You can see it's using still that size of 1. So we have to actually recalculate the bounds. So now we're in LOD 0. And as we move away, let's see, it very slowly is going to switch. So we could actually have this switch a lot earlier. So I would actually say we can probably have that be more like 80%, and then this becomes more like 40. So we're at LOD 0 still. And that object size, it's definitely calculated something that I would say is probably too large. So I think we could actually halve that maybe. And that seems about right. So we're at LOD 1 there. We've switched to LOD 0, and the difference, you can see it, like you do see a bit of a pop here with those. So we've got a slight bit of a pop with the visuals there. Not a huge one. Like it's something where if you're moving towards it, you wouldn't necessarily notice it, and we could definitely push back sort of where that happens so it's taking up less pixels on the screen. We could configure a little bit of crossfading. So if we do a bit of a crossfade on this, then we can see, okay, how does that go? So we still do get a little bit of pop, and you actually can see the Z fighting there. So that's an important thing to be aware of. It's a little bit hard to spot, but you get these little shimmers, which is two sections of mesh too closely overlapped. So we've got it that this is now much, much cheaper. You know, we have something that's 4.78% of it. So we could also make material changes if we wanted. We could be using different shaders here. We could be using different mesh rendering settings. So at that distance, it might not, for example, cast shadows. Now, as soon as we start turning off stuff like shadows, we can see it is potentially going to trigger more of a pop. Now, it's probably okay with this, but it can, and there we go. So you can see it's much more noticeable of a change. So you can do things like messing with shadow settings, but shadow settings already tend to have a fairly good setup in terms of how they actually work and switch off and that, and there's already a lot of settings for that. So I wouldn't necessarily mess too much with that, but at longer distances where you won't see that pop, or if you're in a fairly dark scene or a scene that has very little in the way of shadows, you probably could get away with changing that. So, okay, that works pretty decently. So that's how we do visual LODing of stuff. What about from a gameplay point of view? Because that's actually something that is really important. So what I'm going to do is I'm going to create a scripts folder, and I'm going to create a script that what this is going to be is a game object, or can I call it a game logic? So the idea being that this is something that functions similarly to the LOD settings that we've already got there. So what I'm going to do is, the idea is this would be a component that you could put on anything and then query. So I'm going to give it a enum for the different LOD levels. So we'll have LOD 0, LOD 1, and LOD 2. We'll give it a public ELOD level. Call it current LOD. We'll make it that it is only privately settable. We'll default stuff to LOD 0. And then we can configure our transition distances. So this would work relative to, for example, the player. So, okay, LOD 0 distance. And then that, so gameplay logic, we don't tend to have sort of a fade, so we don't need to have transition zones. We're going to say, okay, LOD 0 distance is maybe 30 meters. LOD 1 distance is, say, 60. And LOD 2 distance is 90. And we might actually have a cold option. So within 30 is LOD 0, within 60 is LOD 1, within 90 is LOD 2, so we don't need to actually have a distance for the cold. And then we might want to have a query interval for this. So I don't want to necessarily be checking this every frame. Query interval. So we might say every 10th of a second. Gameplay logic, you don't need to tend to query this super rapidly, so I would generally not query it all the time. Then we're going to have a float. Next query time is 0. In our update, well, next query time, we update that. And what I would do is f next query time is less than or equal to 0. Then we're going to refresh our current LOD level. So we'll have an actual function for that, or recalculate LOD. Do the exact same here. And we go and say next query time, and we can just set that to our query interval. Then our recalculate. So this I'm going to do relative to the camera location, but you might do this relative to something else. You could do it relative to multiple different locations. But I'm going to go for the camera location. So what I need to do is I need to get the distance between us and the camera. So I can use a vector 3 distance, but I don't really want to have to use the direct distance, because direct distance is going to actually involve doing a square root, and that's expensive, so I want to try and avoid doing that. Now we don't have a distance squared function or a squared distance one, so what I have to do is I have to go camera main transform position minus r transform position, and then I can get the square magnitude. So the distance squared is that. So what we would say is if the distance squared is less than or equal to LOD 0 distance, then our current LOD is LOD 0. Otherwise, if it is less than or equal to LOD 1, then the current LOD is that. And we have another check for our LOD 2 distance. And the final result after this, if it is not within that, it ends up being flagged as cold. So we can go, that is cold. So this gives us a little handy component that we could place on something. We could be also factoring in that LOD bias if we wanted to tie it into that. Visual and gameplay things, usually we don't want to have them too tightly linked there, because they have costs that work in sort of different ways, and we have different needs, so we can't necessarily update things at the exact same points in time. So that's why I would not generally multiply it by that LOD bias from the quality settings. So okay, that's good. I'm going to create then a second object here, and I'll put actually a second script here first. So call this simple movement. and I'm going to attach the simple movement script to the carriage, along with the game logic one there. So what I will do is with the simple movement, public float movement amount, and we might make that 2 meters. Public float movement speed, and we might make that 2, make it 1 actually, make it fairly low. I'm going to store our position, initial position, and I'm also going to have a game logic LOD, and I'll retrieve that. So logic LOD get component, like that. So now what I can do is in update, well, if logic LOD current LOD is culled, do nothing. Otherwise, I could have it update the position. So what it could otherwise do is we could do a mathf ping pong, which what we could do is use time dot, let's go for time dot time, and we'll use 1, and we can do a mathf sine of that multiplied by 2 pi, so we've got a full length of a sine wave then. We can times that by the movement amount, and I'll chuck the movement speed in here as well. That actually can go into here where we're working with the time. So this will just give us something that will be moving up and down, but only when the camera is nearby. So it gives us our height offset. So in our transform position is our initial position plus our vector 3 up by height offset. So very simple setup, but it's using that culling aspect. So when I run this, you can see, well, it's doing nothing, which means it's culled. And that's because if we go and take a look at our logic LOD, look at what we missed. Very, very easy when you're working with square of things to miss doing the actual squaring of them. The other thing I could do if I found that I was seeing this calculation show up in the profiler is I could actually cache the square of those distances. Would absolutely be something that I could do. So if I run this now, so we can see it's moving. Now if I move the camera back, so it's still moving, it would have gone to LOD 1. We'd now be at LOD 2, so it's not actually rendering it. But it would still be trying to move it potentially. So we could adjust our settings here for the LOD ranges. So I could make it that LOD 0 is 10, LOD 1 might be 40, and LOD 2 could be 55. So now the camera has to move in closer for it to be back to moving. So it's now moving. If I move back out, so you can see it's stopped because we lowered our LODs here. So our logic LODder is working. It's something that we could then attach onto anything. So you could use this on AIs, you could use this on different systems you might have, and it could do a range of different things. You could use it to entirely shut off calculations. You could also use it to slow down the rate that calculations are happening at. So at larger distances, something might tick, or might update only every, 2 or 3 frames, or every 1/10 of a frame. Gives us a way of being able to balance the performance that's happening there. And that's really what the goal of this is it allows us to better balance the performance of the game so that we can actually have more resources available to create a more interesting, more compelling experience for the player up close. So we pour all of our resources into that. We can have higher visual quality, we can have characters doing much more, we can have a lot of more resources available to create that really great experience for people by being able to save that performance at a distance, and it's something that we can integrate fairly readily into our project. These little sort of setups for these would go on the prefab. So I turn this into a prefab, and now wherever I place it, it's going to follow those bits of logic for how stuff appears, when stuff actually animates, which is really valuable. And we can easily have global settings. So for rendering, we've got the LOD bias. We could do a similar thing for the game logic. That's something where we wouldn't generally change that based upon quality settings, but you might, but you want to be a little bit cautious with that because you need to balance carefully for making sure it doesn't have any odd gameplay impacts. So part of that is going to be down to how long range the player is able to be seeing things and interacting with things. If they're able to do that at a very large range, then you might need to never cull the AIs, but instead have them do much simpler logic and find cheaper ways of doing things. You can do stuff like turn off their meshes entirely at a distance. That's going to save a whole bunch. So there's a lot of things that we can do there to balance the performance. So dive on in and experiment with it. See if for your own games where you could potentially apply things like the LODing setup or things like the actual game logic LODing. See where you might be able to apply those for your own projects. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it really helps out, it's really appreciated. If you have any questions, chuck in a comment below. If you're looking for the code for the project, there is a link in the description that is available up on GitHub. You can use it in any of your own projects, commercial or non-commercial ones is fine. If you are trying to find other videos, I do have a video archive, which is a link to that in the description. So that's a searchable archive where you can find videos based upon keywords from the descriptions, things like that. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below. But until next time, bye.